to recover the original array. So we are getting array nums. So actually, this nums is composed by the lower and higher array. So what does that mean? So we are giving this array nums, and we want to find the original array. So the original array is getting by the array I. So by using the original array I minus k and array I plus k, we can get the lower and higher array. So this nums array is composed of the lower and higher array. We just need to find the original array. Yeah. So this is a combination of the lower and higher array. So first of all, we need to find which is the lower array and which is the higher array, and then we're going to use the lower and higher array to find the original array. So for example, the original array going to be 3, 7, and 11. So 11 minus 1 going to be 2. 3 minus 1 going to be 2. 3 plus 1 going to be 4. And similarly, 7 minus 1 going to be 6. 7 plus 1 going to be 8. And 11 minus 1 going to be 10. And 11 plus 1 going to be 12. Yeah, but how can we find this original array 3, 7, and 11? So the problem is going to become easier if we fix this k. So for example, if the value of the k is fixed, so for example, if it is 1, definitely we can find 3, 7, 11 or 2, 6, 10 are going to be the 2, 6, 10 going to be the lower array, and 4, 8, 12 going to be the higher array. So for example, we're going to fix the k. K going to equal to 1. So first of all, this is the lower array, and this is the higher array, and here we have the original combination of the lower and higher. It's going to be, yeah. So first of all, we're going to use the greedy idea. We're going to sort the nums array. So it's going to be something like 2, 4, 6, 8, 10, and 12. Now we want to just fill some numbers inside the lower array and inside the higher array. So if this k is fixed, k equal to 1, yeah, so first of all, we're going to find the lowest number, the smallest number. It's going to be 2. It must be inside the lower array. Yeah. Next, because this k is fixed, k is 1, so this means we need to find the original array. So the original array is going to be 2 plus 1 going to be 3. And what is going to be the higher array? Higher array going to be this 3 plus 1 going to be 4. So this means here going to be a 4. Next, as this number 2 and 4 has already been checked, so we will not check that. We're going to check 6. So we're going to put 6 inside the lower array. As 6 plus 1 going to be 7, which is going to be the original array. And the higher array going to be 7 plus 1, which is going to be 8. Next, as 6 and 8 has already been checked, we're going to continue to check this 10. We're going to put this 10 inside the lower array, and the original array going to be 10 minus 1, which is going to be 10 plus 1, which is going to be 11. And the higher array going to be this 11 plus 1, which is going to be the last one, which is going to be the 12. Yeah, so if we can find such if we can split it into the lower and higher array, and then we can find the original array. So this is the original array, 3, 7, and 11. So we're going to return true. Otherwise, we're going to return false. And this kind of result is not fixed. It can have some other result as well. But if we can get one, we're going to return true. So this kind of problem is called structural problem. So we need to structure lower, higher array and the original array. If we can structure it, we can return true. Otherwise, it's going to be false. As you can see the example, there's another case. If k equal to 3, it is also okay. Like 2, 4, 6, 8, 10, 12. It is also okay. If we can find any one of them, we're going to return true. Otherwise, it's going to be false. Yeah. So now the problem becomes, if k is fixed, we can solve it easily. It seems we can use two pointers to check it. This is pointer 1, pointer L, pointer I, pointer R, and then we're gonna shift the L and R pointer to the right, right direction. But how can we solve this k? And we can just use the brute force. We're gonna enumerate all the possibilities of the k. So for example, the first number, the lower number is 2, so the k can be yeah, so the difference of the two numbers can be 4 minus 2, 6 minus 2, 8 minus 2, 10 minus 2, and 12 minus 2. Yeah, we just need to check the difference of the two numbers. If we know all of them have the same difference, same d, yeah, we just need to check d. So for example, if d equals to 1, so first number is gonna be 2. Definitely, if d equals to if k equals to 1, yeah. So we're gonna check the difference. So the second number, 4 minus 2, if it is 2. So this means it is okay. This 2 is an even number. Yeah, so this means the k equal to 1 is okay, like 2 plus 1, 4 minus 1. And similarly, we can find 8 minus 6, it must be 2. It must be the same number. And 12 minus 10 must be 2, and it is okay, so we can return true. So this is the idea. So this means we're going to enumerate the difference. It can be 2, 4, 6, yeah, so it can be 2, 4, 6, and 8, and 10. And 6 is also possible, like 2 and 8. And here gonna be 4 and 10. And another one gonna be the last one is 6 and 12. And this is also okay. Yeah. Yeah, because like 2 plus 3 gonna be 5. 8 minus 3 gonna be 5. This is gonna be the first number. And then the second number, 4 plus 3 and 10 minus 3. And similarly for 6 plus 3 and 12 minus 3. This is also okay. Yeah, so this is another example we can find. This is also okay. Yeah. Now let's just use this idea to solve the problem. So first of all, we're gonna sort the nums. And this is just the greedy idea. It's easier for us to, yeah, to find after sorting. So definitely after sorting, it's going to be something like 2, 4, 6, 8, 10, 12. And definitely this is going to be the smallest number. If this is the smallest number, this is fixed. We want to enumerate all other cases. And as this is in increasing order, we're going to prepare a low and high pointer to gradually find all the possible cases. So this is why we're going to sort it. So n going to be length of the nums, and then we're going to enumerate the second number. It's going to be I to n. So we're going to prepare a difference. So it's going to be the nums I minus nums 0. So if this difference equal to 0, or this difference modulo 2 equal to 1, so definitely it means it is not possible. Yeah, why? So the difference must be 2 for some even numbers. It can never be odd numbers. Yeah, because the difference is just the two numbers. This number minus this number. It must be even. Yeah, so for example, this is my first number, and this is my first number inside of the higher array. This is my first number inside of the lower array. So it means this 2 gonna plus a number, maybe x, and actually it is k. And this 4 gonna minus a number, which is k. K gonna always be positive integers. Now, what gonna be the difference? So this number minus this number, 4 minus 2, it's gonna be 2 minus k, 2 minus 2 times k. Yeah, this is a 2 and this is a 2, so the final result is going to be even. It can never be odd, or it can be 0, because if k equal to 1, it's going to be 0. So this d can be 0, or this d can be even numbers. Yeah, but if this d equal to 0, definitely it is not possible. This means that they are equal. It is not possible, because this k must be positive numbers. So this is why we're going to check. If d equal to 0, it is not possible. If this d is odd number, it is not possible. Yeah. So if it is not possible, we're going to continue. Now on this d, I'm going to be gonna be an even number, and we're gonna prepare a weighted set, weighted array. Here, we're gonna set it to false times n, and the weighted 0 is gonna equal to weighted I. We're gonna set it to true, and we're gonna prepare a result array. It's gonna be nums 0 plus nums I divided by 2. Yeah, because this number plus this number divided by 2 is our result. For example, 2 plus 4 divided by 2 is going to be 3. 3 is going to be the final result. Yeah, so we need to know about it. Yeah, because we get this number. How can we get this original array? Yeah, so the original array is going to be this one plus this one divided by 2. Yeah, actually it's going to be 3. So this is just by some calculations. Let's just check the formula. So it is the array I minus k and the array I plus k. Yeah, so this means this number plus this number divided by 2 going to be the original number. So for example, the original number is x minus k and x plus k. X minus k gonna equal to 2 and x plus k gonna equal to 4, and 2x gonna equal to, yeah, this one plus this one, 2x gonna equal to 6, and x gonna be 6 divided by 2 gonna be 3. So this is how we calculate it. Yeah, definitely it is just a formula, a mathematical formula. We can calculate it. Yeah, so we're gonna, if it is possible, we're gonna put the first possible result inside the result array. Now we're gonna check the next possible case. So we're gonna prepare a left and a right, a low and high. Yeah. So the left gonna be starting from a 1, and the right gonna starting from I plus 1. Because I is for high, I plus 1 gonna be the next number. Because 0 is chosen, and we're gonna choose the next number. It's gonna starting from index 1. Yeah. And here we can just control the high pointer while r less than n, and we can check if l less than n and weighted l, this is a weighted, so l gonna plus equal to 1. Now after this if check, so this means yeah, I think it's gonna be a while check. Yeah, it's gonna be a while check. Now we're gonna use r less than n and nums r minus nums l. It is less than d. It means r gonna plus equal to 1. We want to make it possible. Yeah. Still, while r equal to n, or nums r minus nums l more than d, this means it is not possible. It is too big. Because we want to fix it to be d, and then it is more than d. It is not possible, so we're gonna break it. Yeah. Now this means everything gonna be possible. So we want to put it inside the result array. But before that, let's just check the weighted set. Yeah. So let me copy and paste. So the weighted L and the weighted R gonna be true because we've already weighted this L and R. It is possible, it is okay. And here we want to put it inside the result array. So this is an L. So here we're gonna use append. We're gonna append this value. So yeah, now out of this while loop, yeah, now after that we need to update this L and R. L gonna be L plus 1 and R gonna be R plus 1. we're gonna check the next possible case. Yeah, or we can use if, because this is a while check, and each time, yeah, I think the while is safe. Let me just use while. So after that, I'm gonna check the length of the result array. If it is equal to n divided by 2, it means it is okay. We've already find it. If it is not, we're gonna return an empty array. This means we didn't find it. Yeah. So this is the coding, and it is a lot of code. And basically here is just about the two-pointer, but it is in the same direction. And we're gonna use our weighted set to check on which position is visited. And the time complexity gonna be n squared. N gonna be 1000. Now let me just run it to check if it works. As you can see, it works. Now let me just submit it. Yeah, it didn't pass for some testing case. Let me check. Yeah, this is a 50, 100. It should be 51. Minus 50 and 51 plus 1. Yeah, it's gonna be this one. Minus this one is 100. This one minus this one is 100, and this one minus this one is 100. Yeah, I don't know. Let me just check. What if I use it check? It can pass for some testing case, but not all of them. Yeah, what if I just use if check, not while check? Yeah, it should be while check. It didn't work. Yeah, let me just check my submissions. Why? Yeah, maybe copy those code. I don't know. Yeah, it seems I made a mistake around these areas, but I don't know which one. Sending 1 to I plus 1. Yeah, I think if and while should be okay for this one. Now let me just run it. Yeah, now it works. Let me just submit it. Yeah, now it passed for all testing cases. I think the problem is coming from this if tag. If I use a while, it didn't work because the break gonna just break this while tag. It didn't break this while. Actually, I want to break the outer while. This is why I cannot use a break. I cannot use a while. I have to use if tag. Yeah, so we have to be careful about this kind of coding because we want to break this while loop and instead of this one. If we use a while loop here, definitely it didn't work. We cannot break. We only break this one. Yeah. Now let me just resubmit it and to tag. As you can see, now it works. Yeah. I think that's all about it. Thanks for watching. See you next time.